All right, so let's talk about encryption. This is something that we will be talking about today, encryption. And this encryption will also be used here when you cover Cloud SQL, Cloud Spanner. You will see how Google Cloud can provide you protection for your Cloud SQL managed instances, managed databases, and Cloud Spanner instances also. So let's talk about this topic. So we'll try and cover this part today, which is encryption at rest in transit, accessing them outside from portal. So let's understand this service. When it comes to encryption, first of all, I'm saying what is the objective here? The objective is, as we know that Google is a public cloud. And since it is a public cloud, it is accessible to everyone out there, or its services are available to all the customers. Any customer can sign up to Google Cloud and can start to consume services from Google Cloud, which basically means that public cloud provides shared hardware, shared hardware access. So the access is shared, which basically means on the same hardware, you have your workloads, which includes application, data hosted. And on the same hardware, you have another customer hosting their workloads. There's a high probability of data leak. There's a high probability of you accidentally accessing data that belongs to other customer and vice versa. That could happen. That's what the perception or the assumption is. But that is not how it is configured. Google or any public cloud service provider, they will ensure isolation. And that isolation is created by virtue of services that you deploy in Google Cloud. So for example, isolation for when you are running, when you are hosting applications in Google Cloud or on the top of a compute engine, that isolation for compute engine is created with the help of VPC. So you basically deploy your compute engine instances inside a VPC, and that VPC belongs to your project ID or belongs to your customer account number. And that is how Google is creating isolation. Same is the case with App Engine, which is a PaaS service, platform as a service, which is equivalent to Compute Engine. The only difference between Compute Engine and App Engine is that in Compute Engine, you manage the administration, maintenance, high availability, patching, and other heavy lifting. However, in App Engine, Google manages the underlying infrastructure and you only bother about your application and data that it processes. That's what App Engine and Compute Engine is. So Compute Engine is IaaS, App Engine is PaaS. Now the question is, we have additional services that we use in Google Cloud. For example, we use Cloud Storage Bucket. It's an object storage where you will store data that belongs to your business, data which is mission critical for your business. You also have Cloud SQL, which is a managed, which is a relational, I'm saying it's a managed relational database management service. This is similar to relational database service in in Amazon Web Services, and it is similar to Azure SQL PaaS in Microsoft Azure. So you have Cloud SQL also, which basically means that there are multiple. Now, when it comes to compute engine, it uses persistent disk to store data. So you need to understand the data repository. This is the very first thing that you need to know. So a customer must be aware of various data repositories. It could be a persistent disk. It could be a Cloud SQL database instance, which is based on MySQL, Oracle, SQL Server. It could be a cloud storage bucket, etc. So a customer must be aware of all the data repositories. That's the first thing. And the second thing, the second step is to ensure utmost protection of data. So data which is stored in the data repositories, that must be secure. And how do you ensure the security of that data? By encrypting that data. So we basically use the concept of encryption here. So what we do, we basically, so cryptography, it is the domain, cryptography is the domain that deals with, it deals with data security. And how do we secure data? By encryption and decryption. So you encrypt and decrypt the data. Encryption basically means changing a plain text, changing the data into cipher, into a non-readable format by using some algorithms, which is nothing but encryption keys, by using a key that is nothing but some logic that you use in the backend, and only legitimate or authenticated identities or principals will have access to that data because they need the key. That's what cryptography is. So what Google is doing to protect data, if you remember, in when we started this training session, I showed you a video of 6 layers of security at Google Cloud. And as part of that video, you must have noticed that the the employee in the Google data center in the video says that the privacy and security of data is our utmost priority that belongs to our customer. And we encrypt all data at rest. So when it comes to encryption, we have two types of encryption. The first type is encryption at rest, and the other type is encryption in transit. There is another one more type, which is encryption in use, but let's not get into that. Let's keep it at a very, I'm saying let's keep it simple for the rest of the participants. So we have encryption at rest and we have encryption at transit. These are the two types of encryption that we have in Google Cloud, or that we basically use in general terminology to safeguard and protect our data. Now, when it comes to encryption at rest, what Google does by default, Google by default GCP, Google Cloud Platform, protects all data, or you can say by default GCP encrypts all data at rest using its own managed encryption keys. That's what Google does. By default, it encrypts all the data. So when you upload some data into Google Cloud, whether you are uploading that data into a bucket, whether you are uploading that data into a disk, whether you are uploading that data into a Cloud SQL database, whether you are putting it into BigQuery, whether you are putting it into any other data repository, any service that has the capability of storing data. When you put data into that service, by default, Google will ensure to encrypt that data using its own managed keys, which are known as Google managed keys. So these keys are known as Google managed keys. And all data at rest is encrypted using Google managed keys. When it comes to encryption in transit, Google basically uses, for encryption in transit, Google is using TLS, which stands for Transport Layer Security. And Google currently uses TLS version 1.0 to 1.2, depending on what you configure. The best practice says that you should use the latest version, which is 1.3 now. However, that has recently been introduced, so customers still opt to use 1.2 or 1.1, depending on the compatibility of applications also. So that's what encryption in transit is. We also call it advanced SSL or SSL over TLS. Now let's focus on encryption at rest. So when it comes to encryption at rest, as I said, Google is securing the data. Google is encrypting the data using its own keys. But then the question is, as a customer, should you really trust Google for securing your data, for encrypting your data? If Google is encrypting the data, Google can also decrypt it. Google can see that data, read that data at any point in time because they are using their own encryption keys. So if it is their own encryption keys, they can also decrypt it. So there are other options also available when it comes to securing the data in Google Cloud or in any cloud. The same service in AWS is known as Key Management Service, KMS. In Azure, it is known as Key Vault Service. The difference is that here in Azure, the Key Vault is also used for storing secrets, storing encryption keys, and it is also used for storing the licenses. In AWS, we use KMS for encryption. We use Certificate Manager for storing certificates, and we use Secrets Manager for storing secrets and passwords. In Google Cloud, Cloud KMS is only used for encryption and decryption. That's what we use it. So for secret management, for certificate management, we have separate services in Google Cloud similar to AWS. Now the question is that what if I don't want Google to use their own keys to encrypt my data? I would rather want to use my own keys, my own encryption keys. Then there are options available. So I'll explain that from the presentation, from the official presentation. Is the screen visible to everyone?
Yes.
OK, great. Thank you, Kaveh. So when it comes to encryption, as I said, all data stored on Google Cloud is encrypted at rest by default. Whatever you store or upload in Google Cloud, it will be encrypted. Now, data, as I said, data can be stored in various repositories. It just gives you 3 examples here, which is cloud storage bucket, persistent disk, which are attached to your compute engine instances, and Cloud SQL managed instances also. It also includes disk snapshots and custom images. So when you create from the persistent disk, when you create a snapshot, when you take a snapshot, on-demand snapshot, or when you create a snapshot using snapshot policy, that snapshot is also encrypted. If you create an image from a disk, if the disk contains the root volume, which is the C drive operating system files, then you create an image from the snapshot. When you create an image, that image is also encrypted. So that's what encryption is. Now, when it comes to encryption at rest, as I said, each data chunk that is stored in Google Cloud is encrypted with a unique data encryption key. So Google uses a unique encryption key to encrypt all the data. And that's where you see that when it says that data is uploaded to Google Cloud, data is chunked and each chunk is encrypted with its own encryption key. Chunks are distributed across Google storage infrastructure. So basically, in a layman terminology, you can understand that Google is protecting our data by default, putting its own encryption method. That's what Google does. And then these data encryption keys are encrypted with wrapped keys, which is known as key encryption keys and stored with data. So since it uses a separate key to encrypt each chunk of data, it wraps all those encryption keys into the main key, which is known as key encryption key. That's what Google does in the backend. And these key encryption keys are stored and used inside Google's central cloud key management service. So Google also uses the same KMS service to generate encryption keys and then use those encryption keys to encrypt the data. That's what Google does. So this is how it is happening when the decryption is required, when you need to access the data, when you download the data or try to access the data over the internet. What happens? It will use the data encryption key the one that was used to encrypt the data, the same key will be used to decrypt the data. That's what Google does. So that's how Google is encrypting the data. Now it says all data stored on Google Cloud is encrypted at rest by default. This is, we are reviewing it. Then I will show you the demonstration. We'll navigate to the console and I'll show you all the concepts. So it says all data encrypted in Google, stored in Google Cloud is encrypted at rest by default. That includes data in storage bucket, persistent disk, cloud SQL, etc. This etc. basically means any storage repository that we're talking about here. All data in Google Cloud is encrypted with a unique data encryption key. Data encryption keys are wrapped, and decrypting data requires the unwrapped encryption keys. So that's what we do. Now, when you upload data into Google Cloud, you will see an option. So what Google does by default, Google hides this option because it is by default encrypting your data using its own managed keys. It will hide it. It will hide this information from the customer, considering it not necessary. But when the customer wants to encrypt the data using its own encryption key, then definitely customer will need to seek, identify this option and change it to the one that customer needs. Okay. All right. So you can see that the second option that is, it says by default key encryption keys are fully managed by Google. There is nothing to enable or configure. You don't need to do anything here. It is just by default. Then comes the default encryption. Now, when it comes to encryption, there are additional terminologies that you need to be aware of. Consider key as a password that you use to authenticate. And let's say your official laptop, every time you need to log in, you provide the password, it authenticates and it allows you to log in. However, you don't use the same password forever. You change your password every 45 days, 60 days, 90 days, based on the password rotation policy. And while you change your password, you also select a difficult password because that is part of your password complexity requirement as part of your password policy. Same is the case here. It says that when Google is rotating, when Google is encrypting your data using its encryption keys, Google is also changing the password. In the key context, it is known as key rotation. So Google is rotating the key every 90 days. And when it rotates the key, it actually creates a new version of the key. It doesn't mean that the previous version is not available. No, previous version will still remain available because all data that was encrypted using the previous version can only be decrypted by that version. So it will continue to use the previous version, but any new data that you will upload in Google Cloud will be encrypted using the new version. Google will store up to 20 versions at any point in time. And re-encryption of data is required at least once every 5 years. So every 5 years, which is a very, I'd say, flexible and lengthy, time frame wherein you need to re-encrypt your data. So that's about the default encryption. But then the question is, I do not want anything default. I want to use my own encryption method. I probably want to create my own encryption keys, control them end to end when it comes to rotation, when it comes to disabling the key, when it comes to managing the key lifecycle. I want to manage it all by myself. And for that, I have a service that Google provides me, which is known as customer managed encryption keys. So I can use Cloud KMS to generate a customer managed encryption key. And this encryption key, I will be able to generate, rotate, and delete it when not needed. Those keys will be stored in Cloud KMS. Cloud KMS is the service where these customer managed keys will be stored. So you can see here the second radio button is customer managed keys, which says manage via Google Cloud Key Management Service. So that is my second option that I can use. How do I create a key? I will show you in the demo. Okay, then comes the third option. But before we understand the third option, let's understand the drawback of the second option. So my second option was customer managed encryption key. In short, we call it CMEK. The drawback of this method is since you are generating the keys in Google Cloud using a service provided by Google Cloud, there is still an iota of probability that Google may still have access to your data. So if you want to take an example, we can take an example that you have your home, you give responsibility to somebody else to protect your home. And that person is actually locking your home when you go out and opening it for you when you come back. The key is with the person. So it is evident that if that person wants, in your absence, that person can unlock the door and get inside and do anything. That's the first option, which is Google managed keys. The second option is that you don't want that person to use their own lock. What you do, you basically ask that person to bring a lock. The person brings a lock, gives you the key, you lock the door, and then you go out with the key yourself. Now you will still have an iota of probability that the person may have a master key because they have brought the lock. He or she has brought the lock. That's the same case here. Even if you're using Google managed encryption key method, even if you're managing KMS key, there is a high probability that Google will still have access to it, which is true. I'm saying if you understand it from technical terminology, yes, Google can access your data because Google is storing that key in its cloud platform. That is where the third option comes. The third option is customer supplied keys. Customer supplied keys. Now, this is where you will go and bring your own lock. You will purchase your own lock and give it to the person and say, from today onwards, we will be using this lock. Now the person doesn't have access to the key. So you lock your home yourself, you take the key with yourself and you go out. The person cannot access your data, cannot get into your home because they don't have access to the key. That's what customer supplied keys. So Google also gives you an option wherein you can bring your own keys into Google Cloud. You can use your own keys to encrypt and decrypt data. That's customer supplied keys option. Now, when it comes to customer supplied keys, there are two options that you can use here. Google provides you those two options. First is external key store and second is HSM, which is stands for hardware security module, HSM. So this is the option that Google provides. External key store basically means you can there are third parties, there are companies who provide encryption services. They'll provide you encryption keys that you can upload into KMS, you can import into KMS, and you can use those keys to encrypt and decrypt your data. That's external key store. Then comes hardware security module. This is a hardware based encryption method. And this basically hardware security module is a device that you basically, it looks similar to this. I can show you hardware security module. So this is the hardware security module, HSM. Cipher is one of the key player or very famous and trusted company when it comes to HSM. Similarly, you have another Thales, which is also a leader when it comes to data security or cryptography. So this is how an HSM device looks like. Using this HSM device, you can also generate keys and then you can use those keys to encrypt data in Google Cloud. So that's the option that Google Cloud provides you. However, this is an expensive solution. Purchasing an HSM device, it doesn't come for a couple of thousand rupees. It comes for hundreds of thousand rupees. It's an expensive solution, but most of the financial institutions, they use their own HSM, hardware HSM, to generate encryption keys, and then they will use those encryption keys everywhere, in on-premises, in public cloud, private cloud, in co-locations, in hybrid cloud, everywhere. So that's HSM part. Now for HSM, Google also gives you an option. Google says that if you don't have enough budget to purchase your own HSM device, then I give you this option. So Google provides you Cloud HSM. It's a Google service, Cloud HSM. It's a GCP service. And in this service, Google will use an HSM device, HSM hardware security module, to generate encryption keys, share it with you that you can use to generate your data. But then the risk will remain the same. If it is Google HSM, then Google may have access to it. So if you want to be 100% confident, and if you want to get 100% peace of mind when it comes to data protection in cloud, either use a third party key management service, I'm saying an external key management service, get the keys from them, import them into Google Cloud Key Management Service, and then use them to encrypt the data. That's first option. Second, if you can afford to purchase an HSM device, you can purchase an HSM device, use it to generate encryption keys, and use those keys to encrypt the data. In both the cases, the keys must be imported into Google Cloud. You will need to import the key. The key will be stored in KMS service, and you can use that key to encrypt or decrypt the data. So this is about encryption in a nutshell when it comes to encrypting, when it comes to protecting the data in cloud environments, whether it is Google Cloud, whether it is Azure Cloud, whether it is AWS Cloud, the concept will remain the same. Azure also provides Microsoft managed keys. AWS provides AWS managed keys. Google provides Google managed keys. Similarly, Azure has Key Vault. AWS has KMS service, key management service. Google has Cloud KMS service. Azure, AWS, and GCP, all the three clouds provides software HSM, which is known as Cloud HSM service, and they all support an external key store wherein a customer is allowed to bring their own encryption keys, import them into the cloud, and then use those keys to encrypt the data. So it is the same story in all the three leading cloud service providers that you can use. Any questions so far, guys?
No.
Okay, let's look at the demo. If you have access to the cloud environment, you can also do it simultaneously, or else the session is getting recorded. You can refer to the session recording and practice it in your spare time. So we'll talk about demo. So what are we going to do? I'll give you two demos here. The first demo is we'll provision Cloud KMS service and configure. We'll provision and configure Cloud KMS service. Cloud KMS service. And when it comes to provisioning and configuring, we're actually we will actually generate. So we will generate, manage, disable, delete, encryption keys. Delete, So we'll generate, use, manage, disable, and delete encryption keys. That's what KMS service is. So that's the first thing that we will do. Then, in order to showcase the live use case, live implementation of KMS, what are we going to do? We'll provision a cloud storage bucket. And while we provision a cloud storage bucket, I will showcase the use case for encryption there. So we'll provision a cloud storage bucket. And in the cloud storage bucket, we will explore encryption use cases. And when we cover Cloud SQL, probably next week, we will start with databases. When we cover Cloud SQL, we will also show you the encryption part using the same service in Cloud SQL also. So that's what we are going to do as part of the demo. So let's get started, guys. So first, let's go ahead and understand the Cloud KMS part. So I'll navigate to the console. OK, I'm in the project. So let's go ahead and create a storage bucket. Now I have done the cloud storage bucket. I've covered cloud storage bucket service in detail in the previous sessions. So you can refer to the session recording if you need that information. The only thing that I did not cover at that point in time was the encryption, because I wanted to cover encryption after participants have got good understanding of Google Cloud. So we are covering encryption today. So now what we are going to do, we are going to create a bucket. And I'll show you where exactly encryption comes into the picture. So you provide the bucket name, let's say sample bucket. You need to make sure that it is unique because it has a public endpoint. Google doesn't allow you to create a bucket with uppercase. It has to have a lowercase. Google doesn't allow you to use uppercase letters anywhere in Google Cloud. It mandates to use lowercase alphanumeric characters and numerals for naming a service. So it has to be unique. It is unique. I'll continue. I'll just go with a single region. I'll go with the default options. This is where the encryption comes. Now you can see this is by default hidden. This is my last option. When I choose how do I access, how do I want to protect the data, then I have a button to create the bucket. This data encryption part is hidden. However, this is where you need to see. So you can see carefully. It's by default, it has Google Managed Encryption Keys selected. This is the radio button which is selected. So Google is using its own encryption keys here. It's Google Managed Keys. So when I create the bucket, Google is going to encrypt the bucket as well as all the objects that I will upload in this bucket in future using its own managed keys. So my bucket is created. If I upload some files into the bucket, let's say I'll upload this file which is comparing between AWS, Azure and GCP into the bucket. Let's see what happens. So file is getting uploaded into the bucket. Now file is uploaded into the bucket. And if you look carefully, so let me just get rid of these options. OK, now when you look carefully over here, it says that this is the sample bucket. Now, when I go inside the bucket, I see this file and I see the encryption type as Google Managed for this object. If I click on the object, I can also see this information here, which says encryption type Google Managed. So Google is managing the encryption. It's Google managed encryption, and whosoever has access to this URL, they will be able to access the data. So if I copy this URL, and let's say if I open another incognito window and type this URL here, this is authenticated URL, which is similar to signed URL. I will be able to access the data. I will just need to provide the credentials. However, if I want to access it over a public internet, then I will need to create a public URL for it. So that's how it works. So this is Google managed encryption. Now what I will do, as I said, I don't want to, I don't want Google to use or Google to provide encryption security services. I want to use my own encryption keys. For that, I will create a cloud KMS service. So when it comes to creating cloud KMS service, it involves 4-step process. There's a 4-step process here. So understand the 4-step process. Provisioning a cloud KMS. It has 4-step process. The first step is enable cloud KMS API. Any service that you will provision in Google Cloud, when you navigate to that service for the first time, you will need to enable the API so that the instructions that you provide will be collated and sent to Google in the form of API instructions. So you will enable the cloud KMS API. The second step is you will create a key ring. Key ring basically means it is a group of encryption keys that you can group together. This is similar to key encryption key or wrap key, key wrapper. After you create the key, after you create a key ring, then you will need to, this is the third step, which is you need to grant. Now the use case is that I want to encrypt my cloud storage bucket and all the objects in the bucket using the KMS key, using my own customer managed keys. So for that, this is the third step, which is I need to grant cloud storage service agent access to KMS service. That's the third step. And the fourth step is select customer managed keys for encrypting the data. These are the 4-step process that you need to do in order to work with KMS. So first you will enable the API. Second, you will create a keyring. Third, you will grant cloud storage service account access to KMS service. And fourth, you will select customer managed key for encrypting the data subsequently. And then in the end comes the management, or you can say administration, which basically involves a couple of steps, couple of regular steps, I would say, and those are, so when it comes to management administration, it basically involves uh, managing key versions, performing or performing manual key rotation, or automating key rotation. It involves managing access to KMS service and customer managed keys, and then probably disabling the keys when not needed, and scheduling the keys for deletion. These are the management tasks that you need to be aware of. So these are the main tasks that you will find yourself doing as part of KMS service. Let's move on. So we'll first provision a cloud KMS. So we'll navigate to KMS service. So we navigate. Okay. Some synchronization issues. Let me just refresh my screen. Okay. So we'll navigate to KMS service. You can directly search for KMS and it will say key management, or the other method is you can click on these three horizontal lines, navigate to security at the bottom. Under security, under detections and control, you will find, under data protection, you will find key management because it's a data protection service. So here we see the key management console. There was a key which was generated in the past. So I'll show you how do we start with it. So the first thing was to enable API. Since this service was already in use, so whosoever clicked on this service for the first time, they've already enabled the API. So that first part is complete. So this enabling the API part is completed. Second is create a key ring. So we'll move to create a key ring. Now, why do we create a key ring? Key ring is like a keychain in which we can organize our keys for various objectives. That's what key ring is all about. So we'll create a key ring first. So we'll create a key ring and we can say this is next turn KMS demo. So I'm putting the key ring as next turn KMS demo. Then the question is, do you want regional or multi-region? If you say regional, then the keys that you will create in the key ring will only be used or can only be leveraged in that region. If you say multi-region, then the keys can be used in all the regions of Google Cloud. So to optimize the cost, I'll go region and I'll select the region. I'll say I want to create a key ring in US East 1, which is South Carolina. That's it. So you're just creating a keychain, or let's say a folder in which you will keep all the keys. So it's a container basically. So keyring is getting created. After the keyring is created, it will ask you to move on to the next step, which is to create the encryption keys. You can create multiple encryption keys inside a keyring. So we'll create an encryption key. It says a cryptographic key is a resource that is used for encrypting and decrypting data or for producing and verifying digital signatures. A key can have multiple versions. So we are going to create a key. So I'll say I'll create one key, which is next turn prod key. This is the name of the key. Now this is where you will select what kind of key you want to create. If you say software key, then this is equivalent to cloud customer managed key. If you say HSM, then you are using cloud HSM service of Google Cloud. And if you say external, then it means you're creating an external key store, and then you will bring keys from outside. Those are the three options. So it says, so we'll go with the first one, which is we want to create KMS key. So we select software, hit continue. Then it says key material. So we are going to generate the key. If you had selected external, then you would have selected import key. So you can import the key from outside. Then the purpose. What will be the purpose of the key? So yes, the purpose is we want to create symmetric key, which is a single key for both encrypt and decrypt operation. You also have asymmetric option wherein you use a combination of public and private key to encrypt and decrypt. So to make it, to make it simple for rest of the participants, I'll go with symmetric key, which is the most preferred, most useful option 99% of the customers go with symmetric key. So you select symmetric key, then you hit continue. After that, it will say, all right, now you are creating this key. Google is asking how frequently you want to rotate this key. You want to rotate the key, which basically means how frequently you want to create a new key, another version of this key. So here we'll select 90 days, 180 days, whatever you want to select. The minimum is 30, 90, 180, 365, and you can also put custom duration. And you can say manual, never, which means you will manually rotate it when it is needed. So I'll say that let's do it 90 days. When you say 90 days, it will automatically calculate the 90 days and it will say from today, 90th day would fall on 28th of August. So your key will be rotated on this date. So you'll hit continue. Then it says additional settings, which is the duration of schedule for destruction. Now what happens when you decide to destroy a key? Destroy basically means delete the key. Google will not delete it instantly. Google will still keep it. It is like putting that data into recycle bin. It will put that key into recycle bin and it will give you 30 days to reconsider your decision and probably change your mind and retain the key. So that's what 30 days. It says if no value is added, the default value of 30 days will be applied. So I would say 7 days. I'm saying that when I decide to destroy the key, do not destroy it with immediate effect. Keep it for 7 days. If in next 7 days, I will get to know the impact of that operation, impact of that action. And accordingly, I will either let it get permanently deleted, destroyed, or I will request to retain it. So that's what the additional setting is. Then comes version label. Label is nothing but a key value pair that will help you to identify the purpose, owner. It is like tagging. So I can put a label, let's say it's all small letters. If you put uppercase, it will not accept it. Cost center, I'll say is Nextern. So which means that Nextern is paying for this key. And in the end, I will hit create. So I'm creating the encryption key. This is how you create an encryption key. You can say the key is now created. This is my key ring, Nextern prod key. If I go inside the key ring, I will see my key here. So this is my key, which is Nextern prod key. And now I will use this key to encrypt and decrypt the data. So this is my key that the KMS key that I have created. If I want to create more keys, I can also create more keys here. I'm saying this is the main page. This is my keyring, which is Nextern KMS demo is the keyring. Inside that keyring, I have one key, which is Nextern prod key. If I want to create more keys, I can hit create key and I can create additional keys. And when I click on a specific key, then I see the details of that key. That's how it happens. So we are done with the second part, which is create a key ring and then create encryption key. So we are done with the second and third part. Then comes the fourth, which is granting access. Granting cloud storage service agent access to KMS service. Now, when you navigate to cloud storage bucket and say that I want to encrypt this bucket using the KMS, the bucket must have access to KMS. The bucket should be able to communicate with the KMS service and be able to authenticate and authorize to that key. For that, we need to grant access. How do we grant access? We basically navigate to the bucket. And this is where I am in the bucket. Inside the bucket, you see settings. In the second settings, you will find the service account agent, the service which is getting executed every time you perform an operation on Google Cloud Storage bucket. Here's the agent. This is the service account. You can see cloud storage service account. This is the information. This is the agent that needs access. So I have already provided this agent access. So you will copy it, and this is how you will provide access. You will navigate to KMS once again. And in the KMS, this is my key. You will navigate to the key, and in the key, these are options. So right now we are on the versions. We'll navigate to permissions, and here we will grant access. So in the permissions here, you can see you will grant access. So you will come to the permissions, and here you will click on grant access. And here you will put the principal, the one that you've just copied, and provide this principal the access, which is KMS crypto operator. With crypto operator, it will be able to enable all crypto operations. So these are the options which are available. I'm saying you can also provide this option, which is cloud KMS, crypto key encryptor and decryptor. With this capability, it will be able to encrypt and decrypt operations. You can also provide this one. So what we are doing, we are providing the service account that belongs to my cloud storage service access to KMS key, so that whenever a user goes to that bucket, or whenever a user creates a new bucket and would like to use the key to encrypt the bucket and objects, the service account will be able to authenticate to the service. It's like service to service communication, which is similar to roles in AWS and managed identities in Azure. So you will give access to this. So you can see here the access is granted. It says over here the access is, this is the one which says Google Storage Service Agent. And this service agent or service account has been provided cloud KMS crypto key encryptor decryptor. And it is provided access for this key only. Only for this key, not for the other one. If you create another key, you will need to repeat this operation once again. So now that my service account, Google Cloud Storage Service account, has got access to encrypt and decrypt using this key, I will navigate to my cloud storage bucket. This is my cloud storage bucket. Now I can create a new bucket and use the encryption key that I've just created, or I can change the default encryption method for an existing bucket also. So this is my existing bucket, sample bucket. I can change its default encryption method. So what I will do, I will click on the bucket. I will navigate to permissions. Sorry, protection. And in the protection, I will see encryption method. It's not here. So I'll just need to see where it is. Configuration. Over here, it is here. Under configuration, it is there. So under configuration, you see encryption type. And here it says Google Managed. And there's a pencil sign, which is an edit option. You can click on edit. And here you can change the key. So it says by default, it is this. You can click on Cloud KMS, and then you will need to select your KMS key. So I'll select my Nexternal prod key here. And it says you do not have permissions. Why it says? Because it probably has not updated yet. So I'll just click on save, and it is saved. So that was just a synchronization issue wherein it was saying you don't have permission, but I did grant service account permission to KMS key. So now you can see my default encryption method is customer managed key. Now I'll go back to the bucket and I will upload some additional objects to it. So I will upload one more file here in the bucket. Let's say AWS, Azure, GCP, Associate Cloud Engineer Practice Test. Or let's say GCP, G Cloud Commands. So I'm uploading another object, and you will notice that this object will now be encrypted using my KMS key, because I've changed the default encryption method for this bucket. So now that the object is uploaded, which is GCP Cloud Commands, and if you scroll it to the right, you can validate that it now says customer managed. The previous one says Google managed. This one says customer managed. And if you click on this object, you will also see the key using which it is encrypted. So you can see the encryption type is customer managed, and this is the key, which is it shows you the project name, then the location, then the key type, then the key ring, which is Nextern KMS demo, then the key, which is Nextern prod key. So now all the subsequent objects that you will upload in this bucket, they will be encrypted using this customer managed key. Is it making sense, guys? Yes, no, maybe. Are you with me? Guys, can you hear me?
Yes, sir.
Okay. So now you can see the key has been changed and I'm encrypting the data using customer managed key. So any file that I will upload from this moment onward into this bucket, it will be using the new key or the customer managed key that I have just provided. So that's the concept of changing the existing encryption method. Now what will happen? You will notice that all the new objects are using the key, customer managed key, but any existing object will continue to use the same encryption method. So it will not change the encryption method for the existing objects. Only the new objects will be encrypted using the new key. Now, if I create a new bucket, I can also see the same behavior. So I am creating a new bucket and I'll say I'll change the name. I'll just go with the default options. And in the encryption, I'll select KMS. I'll select my key and hit create. Now this bucket is getting created using the new encryption key, using a customer managed encryption key. So from this moment onward, any data that is going to be uploaded into this bucket will be encrypted using the customer managed key. So you can see I'm uploading some files. Let them get uploaded. You can see all the 3 files are uploaded and they all are using customer managed key. So they all are using the same key, customer managed key. You will also see the key version. When I hover the mouse there, you will see the key version also, which is version 1. So they are getting encrypted using version 1. Now let's go back. Now I'll duplicate this tab to show you the implication of it. That how does it work? So I'll navigate to the KMS service and let's look at the operations that we can do. So we have completed this task. We have provisioned a cloud KMS service. Using that service, we have encrypted the data also. That's what we have done. Now we'll see this management task. So first, managing key versions. So this is how we manage. So I'll navigate to the key that I've created. And I will see the version of it, which is right now the version is 1. I can rotate this key. Rotate basically means just imagine that it has been 90 days and now I'm manually changing this key. Or I have some suspicion that probably my key is compromised. Somebody may have access to my key. So just to be 100% sure, I can rotate this key. So I'll click on rotate key. It says when you rotate a key, this happens. A new version will be created and made the primary version. New data will be encrypted with the new version. Older version can be used to decrypt data. Data encrypted using older version will remain so unless explicitly re-encrypted. So I will click on rotate. Now, when I rotate, it will create another version of the key, which is version number 2. And you can see it is enabled and primary. So now version number 2 is the primary version. Now I'll go back to my bucket, refresh the page.